torquing this to?
96.
Which comes?
Mm-hmm. Okay. Before we put the chain on, we need to check our sprocket alignment. And so what you do is you put the sprockets on without the chain and put the bolts in so we draw everything up tight and it isn't going to be disturbed by us checking it. And just put them in snug. And then what we're going to do is we're going to take and put a straight edge on the sprocket and lay it across the other sprocket and see that we have alignment within the specified amount. And this of course is all in the Harley manual. So both of those are snugged up, and now we'll go get a straight edge and check it. Okay, so we got our straight edge, and what you're looking for is a 10 thousandths difference between these two. That's the max allowable. If it's more than 10 thousandths, you're going to require a different spacer behind this sprocket. So they have different washer thicknesses, I believe in 5 thousandths increments that will get you there. Now when I set this on the sprocket, I can't get my 10 thousandths in here. Now if in this case this sprocket is out farther than that one, so of course I want to align my straight edge with this sprocket. Of course if this one was out farther, I would align it with this face and then use my feeler gauge down here. So in our case here we have less than 10 thousandths, and of course I'm clearing that sprocket. So we're within spec. We can continue to assemble. We'll pull these back off, put the chain on, and torque them down with the red Loctite and move on. So next we have the outer cam chain assembly. Make sure that the cam washer is still in place. Timing this flat in line with that line, and of course your timing marks on your chain should line with the two bores. When you're done here you can put a straight edge on here, but of course this rear cam has a missing tooth, if you will, on the splines, and you have to align that with the missing tooth in the sprocket. Hopefully you can see that down in there.
Yes.
And we just align that. Before we get that in there, we got to get our hydraulic tensioner in place. And sweep this in here. Push the hydraulic tensioner back, and it should slide right on there, like so. Install the bolts with the red Loctite that was supplied with the kit. You can be pretty generous on that one because there's no oil passages to the plug or problems of that nature. The pinion, is not such a bad idea to clean the bore because it's got oil in there, and oil of course can contaminate your Loctite. This is Loctite 262. And put some on the bolt and put it in. So now we're going to torque the rear cam and the pinion bolt. We have a locking tool here that we could use to hold the thing from spinning. As well, you could leave it in gear and put the rear wheel on the ground and hold the rear brake to tighten that if you have an assistant, or it's kind of tricky. You can do it yourself with your elbow, but we'll just torque them up here. Again, it's a 1/2 inch for the pinion bolt and a 9/16 for the rear cam bolt. And there they are, torqued on. We'll move on, I guess, and put the cam cover gasket on there. We got to clean the gasket surface good so that the gasket can seal. Use a little brake cleaner solvent to on your rag to get it good and clean. After you got the gasket surface clean, put on the new gasket, and of course clean the cam cover, get all the oil out of here, and get it ready to go on so that everything's dry. And put it on here. A little Loctite on all your bolts, and torque them to spec.
You're torquing those every other bolt?
Just stagger it, you know, not so it's even. There's actually a bolt torque sequence in the manual. The important thing is just to not walk straight around it. Kind of increase the clamp load evenly. And then when you get towards the end and everything's torqued, you can kind of just walk straight around.
Does the family still own the original farm? They probably have it all in trust and stuff.
We're going to talk about pushrod adjustment, and before we do that, I want to talk a little bit about some of the anatomy of the lifter, or give people a visual on what you're actually doing when you adjust a pushrod. So what we have here is a stock twin cam lifter. It's been cut away so that you can kind of see the internals. Basically, you have a spring, a one-way valve up here in this piston body, and then you have the cup for the push rod to fit into in the top, and a retaining pin. Okay, and so what you're doing when you're adjusting the push rod is the gap between the piston and the bottom of the lifter, you're closing that gap. And so for the lifter to do its job and adjust or compensate for the growth in engine height, and as things warm up and change distances, the hydraulic lifter, of course, this travel has to change and take all the valve lash so that your valve train is quiet. So what you're trying to do is to give this the maximum adjustment. You want to adjust this piston so that it's in the center of that travel in between this distance here. Well, if you measure this with the calipers, it's roughly 200 thousandths of an inch. And so what we want to do is adjust this down about 100 thousandths of an inch. So an S&S pushrod has 32 thousandths or 32 threads per inch. So one revolution gives you 32 thousandths of length in the pushrod. So as we try to achieve 100 thousandths, we would want to go one turn at 32 thousandths, two turns at 64, three turns at 96, and then just over three turns is going to give you that 100 thousandths. So what we generally refer to for adjustment on a push rod is flats. Anytime you're talking in terms of flats, you're essentially referring to a six-sided hexagonal shape. And so you stick a wrench on a set of flats, because a wrench is basically shaped like this, and so you turn it once, pull the wrench off, and turn it to the next flat on that hex. And so when we turn it 20 flats, we would do that 20 times, okay? Or sometimes they refer to that as 2.5 turns or 3.5 turns, that kind of thing. So it can be termed both ways, either flats or in the number of turns. So